when we've done math about this, the average commercial facility here can improve its status quo, like its revenue, by over 5,000%.
So, hi JC, could you please introduce yourself a bit more and also your company, CultiBio?
Yes, of course. I'm JC Chidiac. I'm originally from Lebanon. I've been living in the United States for over a decade and working internationally ever since I founded CultiBio. It's Cultivation Bioengineering Ltd, CultiBio for short. I founded it because I saw the need for critical information in the CEA industry. A lot of people were getting their information on what to buy, what to build, what to do from technical salespeople. And those people are simply, incentivized to sell what their companies sell. So it didn't really translate into people getting the right information to avoid mistakes and make progress and do more with less. And since then, we've had a really good time, serving people in different countries, helping them avoid mistakes, mitigate risks, generate prosperity and wealth. And it's been a very richly rewarding experience.
And how did you get into agriculture?
I got into agriculture by failures and by accident after resisting it for many years, because my grandfather was a farmer and my aunt took that farm from him at one point, and we would go visit her sometimes and see glimpses into the process and hear stories about weather destroying everything and plagues and pests. Basically work hard every year, spend a lot of money every year, and sometimes get rewarded and sometimes lose everything. So as a younger person, I said many times, I'm never getting into farming. It sounds horrible. It sounds like it's just risky. And then later, once I'd gotten a few different degrees and built up some skills and had opportunities to engage in this from my perspective as an engineer, as a scientist, I found that my skill set allowed me to be useful in this area, and that it doesn't have to be as risky as it is in the past. There's a lot that we can do now to change that outcome and make it more attractive and stable for, families to make a living and for communities to be fed. And that's what attracted me to control environment agriculture. There's many, many levels, as you know, but in essence, it takes the guesswork out of it. It tries to control as many things as a given farmer can afford to control, to make sure that you can actually project in the future, know what's going to happen to an extent so that you can plan your life and get into contracts for your crops and basically have more prosperity.
And so what does CultiBio do? Are you just advisors, or do you run also your own operations? Do you provide technology?
No, up until now, we're just advisors and consultants. So we exclusively sell information. We don't do blogs. We don't do advertising. We don't do sales. We don't take commissions. Not just because these things would be big distractions, time and energy-wise, but they create conflicts of interest. And we have a reputation for avoiding that, basically. When we're hired by clients to advise them, to give them the type of information that is going to save them time and money, they know that we work for them only. And so when I say the best thing for you to buy is this structure or this system or this product, they can rest assured that it's not because I'm making money off of that.
Okay, that makes sense. But I read in the Vertical Farm Daily article that you are looking into some shallow aerial aggregate ebb and flow technique for aeroponics, I would guess, or hydroponics. Could you please tell me more about that technique, because I've never heard that?
Yeah, the abbreviation is pronounced SAFE.
Yeah.
Because it is safe. So where it started, I think a lot of people have experimented with this, and some of those experiments have been dead ends because they didn't really pursue them in the right way, I would say. Because ebb and flow hardware is very old. It's more than 60 years that they've had these in Europe, and it's a well-established irrigation system that nurseries use because it's so versatile. Because you can put flats with, 1 centimeter plugs in there. You can put 1 liter pots. You can put 10 liter pots. Some people irrigate trees on there. It's versatile in that way. It doesn't matter what you put on it. It works the same way. It reduces the need for lots and lots and lots of disposable plastic tubing to drip irrigate a lot of things. It's efficient. It doesn't have any small restrictions that would clog. So, it's fairly foolproof and efficient that way. So during my second master's degree, my thesis was exploring a way to use that hardware to create a versatile hydroponic system that could compete with NFT and DFT, which you're familiar with, and they're very specialized in a way. There's things that you do in one that you don't do in others. They have pros and cons, each one. One is, more thermally stable than the other. The other one has oxygen problems. So you're either running a pump continuously for NFT, or you're running a compressor continuously for DFT. And so we decided to use those expanded clay aggregate, and we put them in the shallow beds and looked into what depth is optimal, what irrigation frequency is optimal. And we did lettuce and basil at the time at the university. And we were out competing the commercial off-the-shelf NFT and DFT, the best ones we could find from the USA. Our lettuce had better growth rates and reduced tip burn and, things like that. It's very interesting. People can read over 1,700 people have read the paper already, according to the downloads. And that fascinated me. And that was where that ended. And another student followed up after me and did that again over there, basically. But after I left that program and was working as a consultant, I continued to explore it. And I found that with aggregate, it's not very scalable. I mean, when you're planting, it takes too many seconds to plant a plant in that aggregate. So I wanted to figure out a way that it could be scalable and less dependent on materials that, in this case, is reusable. The substrate is reusable. You wash it. You have to sterilize it and leach the salt out of it. But I realized that if you just have a plate or a raft or whatever you want to call it, something to close that area, keep it dark, maintain the humidity, that it also works very well. You have to increase the irrigation frequency because there's no retention of water, but it becomes an extremely low pressure aeroponic system where you have an air chamber that is being filled and drained. And now we've tested it on over 50 species of crops in a wide variety of geographies, and we've implemented this at about 6 farms, and it's doing very, very well. So it's not fully commercialized yet, but it's proven itself from, obviously, microgreens, herbs, greens, tomatoes, eggplants, peppers to cannabis. You don't need the big rock wool blocks that people use. You don't need containers. You don't need substrates. We're trying to find, it's not a specialized system or method. It's more for giving the farmers the ability to change their mind. Because if they decide to buy this hardware and install it in the farm, then they can start with microgreens if they want to and have no problems. They can switch to lettuce if they want to and have no problems. They can move to tomatoes if they want. They're free. And I've seen too many of the commercial systems trap people in one area. They start a tomato farm and they buy a tomato system, and then they want to change their mind to lettuce. It means throwing it away and buying a new one. So just because the market fluctuates, the economy is unpredictable, the world's unpredictable, I want to make sure that people have their bases covered.
It sounds like a great system.
It's not foolproof. I mean, you have to know how to use it, and that's why...
Well, of course. Yeah, of course.
Yeah. So we advise, because we have experience in it. We've done a lot of research.
And I've heard you say that South America has a lot of potential in terms of CA farming. CA. But South America is rarely mentioned, or I hardly ever see it being mentioned in regards to indoor farming. So could you tell us what potential you see there?
Yeah, there's a reason for that. If you think about why anybody needs indoor farming, especially like vertical farms and things like that, they make so much more sense in extreme northern latitudes, from Canada to Scandinavia, for the obvious reasons.
I just was in Norway on a vertical salad farm.
Yeah, that was very interesting to see. Thanks for sharing your experience. And so they have extended periods with limited light. They have a very hard time climate controlling without significant insulation. And getting natural light and maintaining your insulation are kind of counter to each other, right? It's very expensive to get the materials that give you both insulation and transparency. And when there's no light to begin with, you can't have it. So it makes sense for local production of certain crops, year round, to do that in those climates. South America is kind of centered on the equator. The majority of it is in the tropics, where you don't have dangerous low temperatures pretty much ever throughout the year in most microclimates. You do have adequate sunlight and more, probably. I mean, for some crops, you have more than enough light, usually. So building enclosed, sealed, climate-controlled boxes doesn't actually make sense in any way, shape, or form. It's not necessary, it's not economical, or anything like that. So when I say the potential for CEA is bigger in the equatorial world, South America, Africa, Asia, it's because of those natural assets. There's a lot of land, there's a favorable climate, there's a lot of sunlight. It's logical, it's natural, that they can more easily and more cheaply and more sustainably produce a lot of food. Now, Western society, let's say North America and Western and Central Europe, are a little bit obsessed with themselves. You know this. They even look down at Eastern Europe and the Middle East, and they're like, no matter what we do, we can't meet their standards. Yeah, but look at the past 2 years in this industry, in those places. You've had some of the biggest, most celebrated, most advertised, most well-funded companies finally come crashing and burning. And from day one, an engineer like me could have told you all of the little things that added up into an eventual failure there. And these are technical things. Some of them added to that, shady money dealings and treating their employees badly. It's a perfect storm.
Mm-hmm.
But
also, Henry Gordon Smith, I don't know if you are familiar with him.
Yes.
He told me that the reason also was that most of these companies didn't even have a farmer on their board. Like there was no actual farmer making decisions. It was just executives from like financial people or something like that making decisions for a farming company, which doesn't make sense.
That's never a good idea. For certain. But even farmers don't know how to build 21st century modern vertical farms. Why would they? So a lot of them were advised by farmers. And if you seek advice from the wrong person for the wrong thing, you'll not get where you're going. The primary reason, I think, is that in their mentality, these Silicon Valley, venture capitalist people, when they're trying to build a company to sell, they focus on IP, like barrier to entry. What is special about what can I protect? What can I patent? What can I monopolize? So they overcomplicate things that actually need to stay simple so that they can have unique control over them. And when it comes to a lot of these companies, they built systems that really didn't make any sense. They were not lean. They had too many moving parts, too many things that need maintenance, too many things that can go wrong. And the farmers looked at this and they were impressed because they're not engineers. The engineers try to do impressive, fancy things to advance their careers, but they're not biologists. And much of what we do is help communication in the industry. We work with companies that have a lot of very skilled people, specialists in areas, but you walk into a meeting with them and you can see that they don't communicate well, they don't speak the same languages. And with the background that I happen to have and help from some of my colleagues, we're able to bridge those gaps. Sometimes facilitate, educate people on multidisciplinary teams so that they can understand each other and cooperate better. The business people need to understand something about farming. The farming people need to understand something about engineering, This is all science, but it's also business, and there's a lot of pieces. So I've ended up being a generalist. And when I need a specialist, I know where to find them.
So you are a Renaissance man.
Yes.
Do you want to add something to our conversation that I didn't ask you about, that we didn't talk about?
Well, when you were asking about the safe system, we can expand that into a methodology specifically for cannabis. that we've also been looking into and that other people have kind of experimented on, but that I haven't seen commercialized or applied at scale yet. And that is the clone to flower method. Typically, people will grow mothers, clone them, and then vegetate these plants to get them to a certain size where they feel that they're ready for transplant into a flowering area. This is separate space, separate energy expenditure, separate labor. It takes time. And then they put them into flower, and any given cannabis genetic is going to continue to stretch a certain amount while it's flowering. This is one of the main things that differentiates true indicas and sativas and things in between. Is the indicas, pure indicas, virtually stop stretching. They have a very low bloom stretch quotient when they're flowering. So whatever plant you start with is going to fill with buds, but it's not really going to change size. Things that are more pure sativa do not stop stretching, have a very high BSQ. While they're flowering, they continue to get high, sometimes quadrupling from where they started. And the hybrids are in between. So for a lot of these genetics, you can completely skip the vegetative period, not have that room, not have those lights, not put energy into that process. Save time in which they can get infected and infested, shorten the whole cycle, and make it very efficient. So you can start with basically 15 centimeter clones that never see any daylight, day length outside of 12 hours, saving energy and time and labor and so on and so forth. You put them directly in flowering, and we've been checking out different planting densities for different genetics, and they will continue to stretch as they flower, and they'll still end up compact enough to avoid many things. Many of the steps involved in the production, like a lot of the pruning and things that people do to improve airflow and get rid of what will be low quality product and, subvert the energy of the plant to the tops where the high quality product is, you end up with less waste all around. And at scale, this translates into huge, huge savings and revenue for these companies and an increased ability to go vertical and stack them. So when we've done math about this, the average commercial facility here can improve its status quo, like its revenue, by over 5,000%. And when there's that kind of potential on the table, you realize that our industry is very, very young because we haven't scratched the surface of what's possible.
Well, where do you get the 5,000% from?
From how much time you're saving in space, how much more you can go higher in space, and the yields we've been getting on some of these that are astronomical. When you put all of that together, it's compounding, like for a given space. Getting more in less time, much more in less time with less work and so on and so forth. It's savings plus added revenue. It becomes a huge percentage. And it sounds unbelievable unless you look through this math in detail. But
5,000%, you don't hear that.
No, and there are a lot of wild claims.
Usually you don't hear
There's
that,
a lot
those
of wild
numbers.
claims in the industry. Right. But when it comes to what we learn and what we read and what we see, personally, me and my trusted colleagues, we like to verify these things. If I take a course or I read an article and I see something stated as a fact, if I really care or if I really want to know if this is true, I go make sure. I run an experiment and I make sure that it matches the reality, that it's achievable. So when people say, oh, hydroponics gives you a 98% water savings over conventional. So that doesn't sound right. It's not true, no. So you go and you do the calculations. You're like, okay, well, let's start from where they're comparing. Conventional. How much water does conventional lettuce take? And then from experience, how much water does this take? Water is evaporating every day. Water is transpiring. You're using water for cleaning. So it's a 70% reduction, which is amazing. But then the company's going to be like, oh, well, ours is better. It's 75. No, ours is better. 80, 85, 90. It starts to make no sense, not based on calculations. So some things sound too good to be true, and they are. Some things sound too good to be true, and we've just been sleeping on them for this long.
Well, thank you for this eye-opening conversation.
Always a pleasure.